Okay, in this given problem, so we are going to transform the following vectors to spherical coordinates at the points given in rectangular form. So we have, okay, the point given here is 10ax. So this is the vector, this is the vector, and then at point P. Okay, so this is not the same as the problem number 7. The problem number 7 is you're only given with coordinates for a point, or point coordinates, which is P. Now, if you're given with a vector, there's another way of solving this, okay? So don't use the previous one that we have the drawing, okay? But the drawing will help us in another way, okay? In another way. And then another one is to transform 10ay given these coordinates. Now, if you notice, the first coordinate is in rectangular, the second coordinate is in cylindrical, okay? Now, our goal is to transform these vectors 10ay to spherical coordinates. And then lastly, so you have 10ag given the spherical coordinates. Okay? So we transform 10ax to spherical given this point in rectangular, 10ay, which is rectangular, to spherical given point in cylindrical, and then 10ag, this is a vector, transformed to spherical using a spherical coordinate point M. Okay? So, okay. So this is not the same method as problem number 7, but this is actually the same as problem number 6. Okay, so you can check it out. No, problem number 6. So let us first solve problem A. So you have the vector here. So I will use the vector, let's say vector A, because of problem number A. Okay, so vector problem A is 10ax. Okay. Sorry. Now, our goal is to find A spherical. So I will use this vector AS, or I will write like this, no, to make it to designate that it is a vector. So our goal is to get the vector AS. So I will use the this how you call this this symbol here. So our goal is to get the spherical is radius. Okay, you get the radius, or you can use R. Okay, no problem, you can use R. We can use R here to make it easier, but maybe there's a confusion, but maybe yeah, we can use R directly. Anyway, we only use one R, and then we find theta, but I think we can use the AR, so to make it more formal, AR, A theta, then AP. Sorry, should be this greater sign and less than sign. Okay, so this one represents the vector. So we want to convert a vector to a vector in spherical coordinates. Okay, now first we get AR. Okay, what is AR? AR is the magnitude of your radius. Okay, now AR is simply the dot product of your vector A in rectangular coordinates dot AR. AR is the unit vector of your radius. Okay? So, very simple. You just distribute. We know that A vector is equal to 10ax. So, this is your 10ax dot AR. Okay. Now, how do you get AX dot AR? How do you get AX dot AR? So, you have here the top view. Then you have the right view, which is you have here AZ, and then you have AX. Sorry, this should be positive AX. Okay, and then this is your, what is this? AR. Okay, the directional vector. It means it's like the direction. Okay, this is the direction for your radius. It doesn't imply any value, okay? Just a direction vector. Then you can also use the front. The front is simply the same as the right, but instead of AX, that's AY. Okay? So this is positive AZ. And then we know that this is theta. Okay? Take note of the angles, the P, the theta, okay? Now, actually, if you look at this, we can actually draw the A theta. Where is the A theta? Well, where is the AP? Now, AP here is this. Okay, at that point, here, we know that this is your AP. Now, actually, we can draw like, we have this direction. This is your direction A rho. And then actually your AP is at this point. This is point. Okay, I'm trying to, at this point here along A rho. So the angle, the direction vector of your AP is this one. Perpendicular to your A rho. Okay? And then your A theta, you can get it from your AR. Okay? Because it's like, it's like you're driving a car, you know that turning left or right, but actually at instantaneous point, you're actually pointing in a direction, no? Okay? You're not making yourself to a curve, no? But you're pointing that way and then it forms a curve, no? Because you have a center, you have a point of reference. So if you move that way, so it will form a curve. Okay? And that curve gives you the spherical form in this case, or the circular form. And then the same is true for your AR. So you can draw like this, no? I want you to visualize this one. This is your AR. But since AR is the radius, so whatever the magnitude of your radius, so pointing that way, no? So that's your AR, okay, or the radius. Now, A theta is actually the what? The normal direction of your AR. The normal, the same as the AP. So this is actually the normal. At this point here, this is normal, okay, or perpendicular, okay, perpendicular to your, or 90 degrees with your AR. So this is actually your, sorry, it's on the other side. Should be going downward. So this is your A theta. So I want you to maybe you will not be able to memorize that one. Maybe in your exam, you are not allowed to get your table, no? But from this, you can actually get the table. This is from the table. Okay, now, so given from the table, we have table here, AX dot AR, which is sine theta here, sine theta cosine P. Okay, so how to get this? So you have AX dot AR. Okay, we have the dot product. We know that dot product is a vector projection. Okay, we project AX dot AR. So we have AX here. So AX, which is in this point, and then you have the AR here. Now, how to project AR to AX, or maybe the other way around, because that product can be commutative. Commutative means you can interchange. You can either project AR to AX or AX to AR. Okay, but it's easier if we project AR to AX. Okay, so we project AR to AX. So AR, because AX is related to arrow, and arrow is related to, okay, arrow, this is actually the arrow here. Okay, sorry, this is AY. This should be AY. Okay, but actually, there's a certain point there that AR is actually there's a certain point here that this is arrow, no? So, but arrow is related to AY if your P is equal to 90 degrees, di ba? If your P here in the top view, if the P angle is equal to 90 degrees, AY is equal to arrow. Okay? You get that, visual imagination. So if your AY, if your P is equal, if your angle P here is equal to 90 degrees, then it will be, this arrow here is along AY. So AY and arrow is equal. Okay? So AR and arrow is actually related in terms of theta. Okay? So how are they related? How are they related, AR and AP? Using the sine theta. Diba? Okay? AR dot arrow is actually equal to sine okay, we know that the dot product, actually the dot product is, because these are directional vector, okay? AR and AP are directional vector. The magnitude of a directional vector is actually 1, okay? So the magnitude of this one is 1, and then the other one is 1. And then we know that in dot product, this is sine or cosine? Cosine? Cosine, right? Cosine. Because you project cosine. Now, the cosine theta here is actually, this is cosine 90 minus theta. Okay? Because this is the cos 90 minus theta. Okay? Or this is equal to sine theta. Okay, cosine 90 minus theta is equivalent to sine theta. Okay, in your trigonometry. So, now, we know this one, no? Okay, so this is your AR.AP. So your AR is projected to A rho with a value sine theta. Okay, if you have a sine theta, then you project AR.A rho. Now, how you get? Now we're going to AX dot AR is actually equal to AX dot the projection of AR dot A rho. Okay, so you understand this one, no? So this is the projection from AR to AX. So therefore this is equal to, now you know that AP, so because AR is now projected to AP, okay? So we can use the term, we can use maybe this term as para it's easier to understand. We can use the A rho prime. So this one actually here is A rho prime. So A rho prime is the projection of AR to A rho. Okay, the vector in the directional vector A rho. So if you dot product na two, so this is equivalent to the AX. Okay, so the magnitude of your unit vector AX, and then your magnitude of your A rho prime, and then cosine. Okay, cosine theta, the angle between the two vector. Okay, the previous one, cosine 90 minus theta, is because AR and AP, the angle between them is 90 minus theta. So you will not use directly theta, no? So 90 minus theta is the angle between AR and A rho. Now in this case, the angle between A rho, okay, we assume that this is A rho prime already. We projected AR to A rho. So the A rho prime is projected to AX. So the angle between them is P. Okay? So this is cosine P. So therefore, AX dot AR is equivalent to, AX is equal to 1. Now, A rho prime is not equal to 1. That's what? Sine theta. Okay, so this is sine theta. Then cosine P. Okay, which is true in our table. Sine theta, cosine P. Here. And then this is true to the other dot products. Okay, so then we can solve for AR. AR then is equal to 10 times AX dot AR is equivalent to sine theta cosine P. Now, the question is, what is your theta and your P? What is the value of your theta and your P? You have 10 sine theta cosine P. It means that your vector AR, your magnitude AR is in terms of theta and your P. Now, as I said, this is not the same as problem number 7. Theta here is not the A theta in your vector AS. Okay? It's not the A theta. Okay? The theta here and the P is at the point P. Okay? So theta and P, angle P, these two angles are from the point P. But the point P is in rectangular form. So how do you get theta and P angles? Okay, then we use the the solution of problem number 7. Okay? Because we're dealing with points conversion or points coordinate transformation. So we transform the point P to spherical. This is spherical, theta and P. So we transform. How to transform? We go back to the drawing. Okay? Given this drawing, then you can easily solve what is theta. Okay? But since these are directional vectors, you can recall the formula for your theta. So theta is, if you notice, this is we're given a rectangular, so you have z value, then you have theta, but you don't have rho. But we know rho is equal to the square root of negative 3 squared plus 2 squared. So this is square root of 13. Okay? Now we have the row here. You have the row. You can imagine in your front view, you have the row here. Okay? Yeah. And then you have the z. So you can solve for theta using tangent. Okay? So theta then is equal to tangent inverse of z. Opposite is rho over z, which is equivalent to tangent inverse of square root of 13 over z is 4. So theta is then equal to 2.42. 42.03. Okay, then you can solve for AR. But still, we need to get the P. How do you get the P? Angle P. Angle P is, we know from the top view, you can get the angle P from the top view. Given the X and Y, you can get the angle P. So using tangent, okay? Tangent inverse of the opposite, which is, what is the opposite of angle P? Y. And then the adjacent X. Okay, so therefore this is tan inverse of 2 over negative 3. So this is equal to -33.69. Negative 33.69. Okay, degrees. So therefore, you have AR is equal to 10 sine of 42.03 cosine negative 33.69. Okay, so AR is equal to what is AR? 5.6. Okay, now we just finished AR. We still need to get the what? A theta and AP. Okay? But we already have some of the values like the theta and the P. Okay, so it's easier to solve for theta. So we have AR now, so we still need to solve for a theta and AP. So solving a theta, so you have a theta is equal to the vector A in rectangular coordinate dot the a theta. Okay, the unit vector a theta. Now, so we have this one. So the angle A is 10AX dot a theta. Okay? AX dot a theta. So, what do you think is the projection of a theta to AX? How to solve AX dot a theta? So, we look at the drawing. So, the theta, a theta. So, a theta is 90 degrees to your AR. Okay? From this drawing here. Okay? From this drawing here, you can see that AR and a theta is 90 degrees. So, can you project a theta to AX? Okay, actually, this is like you have this is equivalent to 10 times the ax dot ar dot a theta. Now, we know that that product is projection. That is cosine. So, what is the cosine of the two vectors in perpendicular form? What is the cosine of 90 degrees? 0. So, if you have two vectors perpendicular, perfectly perpendicular, then the cosine equivalent is 0. So, there's no projection if they are perpendicular. It's like the two roads cannot diverge if they are in 90 degrees. Okay? So, they cannot meet somewhere along the way. Okay? If you are going forward and the other one is on the right, so they cannot meet somewhere along the way. So, in this one, the cosine theta here is equal to 0. So, therefore, ax dot a theta 0. Okay? You get my point? So, we can verify that one from the table. I hope I don't get mistake. Okay? Let's check. ax, ax dot a theta. I think I made a mistake. So it is actually AP, which is 0. Made up. So this should be cosine theta and then cosine P. Okay, I think I made a mistake there. So that's for the AP. So let's go back here. Sorry for that. So that's actually for the AP. So we go back to the a theta. So a theta is in this direction. So the value here ax dot a theta is this one, cosine theta cosine P. So if you look at here, the cosine of looking at this drawing here, the cosine of theta. Okay, so we can derive that cosine theta to from this drawing. So you see this one, from that drawing here, we can draw again. So you have, okay, you have these two drawing, AR, then A theta. So we know that this is the theta, right? From the drawing here in the front view. So by the trigonometry, some identities, okay, that this is theta. Now we know that arrow, this one here as in the front view, as I said earlier, arrow is between along the plane AX and AY. Okay. So how to get that? This is actually here, somewhere here. Okay, so this is your arrow. Now how to get arrow given theta? So you get this one is 90 degrees. As I said, a theta is perpendicular to AR. So this is 90 minus theta. Okay? So that's opposite of this angle 90 minus theta. So that's sine 90 minus theta. And then this therefore equals to cosine theta. Okay? Now this is for your so this is AX that a arrow or the a theta projected to arrow. Okay? And then this one is equivalent to sine 90. Okay? This is equivalent to sine 9 or cosine theta. Okay? So this is the arrow. This is what we call arrow prime. Okay? So the same step as the below. Okay? Arrow prime is instead of sine theta, it is cosine theta. Okay? So therefore this is then ax dot arrow prime is this one, no? Ax arrow prime cosine P. Okay? We explained that one, yz cosine P. So therefore this is 10 cosine theta cosine P. Okay? Because this is cosine P here. Okay, so that's I suppose the one in the table. Okay, cosine theta and cosine P. Sorry for the confusion. But So we already have the theta and your p. So you just replace the value. So again, the theta is we get this one from the angle, between from the coordinates. The vector from the vector. What is the value of your vector at that coordinate? Okay, so theta is 42.03. Then cosine p, which is 5, p is negative 33.69. Okay, so you have your a theta. So this is what? 6.18. Okay. Now take note, this one is in, now this one is should be theta, no? This should be in degrees. So this one is in radian, okay? Or it's in radian. Yeah, it's in radian form. Okay, because a theta should be in degrees. So since our solution here is in radian, okay, cosine of degree is radian. So this one is in radian form. You can convert this one to degrees. Okay, so now we go to the AP. So we have a vector in rectangular form, that AP. Now AP is very simple, okay? So you have angle, vector A, 10AX, dot AP. Okay, so actually AX dot AP, you can check it again from the previous problem here, A and B. This is actually equal to 10 times 1 times 1. So the magnitude of AX, which is 1, magnitude of AP is equal to 1, then cosine, because because from the top view, X is sorry, I think it's not, sorry, it should be, actually this is 0. Okay, if you look at the top view here, okay, the top view is actually this is your AP. And then given your angle P here, this is equivalent here, no? This is the P. So we can redraw that one. We'll erase this one first to show you the drawing. So given from the top view, so you have this vector A, P, and then this is your A, P, and then this is your AX. So this is your angle P. Now, given your trigonometry identity, this is actually equal to the P. Okay? Now, how do you get the projection of your AP? This one. This is your projection, no? To AX. So, it's still the same with the problem B. So, this is 90 minus, because A rho and AP is perpendicular. So therefore, the P here, and then the other side is 90 minus P. Okay? So 90 minus P. So you project this vector to X is actually using sine. Okay? So you see, try to make it a bit easier. So you have the vector here, this one. You want to try to project to this vector, okay? So projecting it, we have AX is, sorry, this one is this is your vector, then this is actually the opposite, no? So this vector versus okay, so this is your, we want to project this one to this part. So how do we project this one? So this is opposite. So this is therefore sine. Okay? So if you notice, this is your vector. And then given given your angle here, which is P. Okay, and then you want to project it like this. Okay, so this is the angle here is sine, no? So the sine P, sorry, if you want to project that one, you need to get this angle. Okay, sorry, this is the angle. Okay, because this angle here, you want to project it here, no? So the angle between them should be called, you get the cosine. Okay, so this angle here is 90 degrees. So this is cosine. So AX dot AP is, sorry, so therefore this is 10, the magnitude AX, magnitude AP, and then cosine between cosine with the angle between them, and then the angle between them is 90 minus P. Now take note, this cosine 90 minus P is actually negative. If you notice, this vector here is opposite to AX. You notice, this is opposite. So therefore, the cosine here should be negative, or negative cosine. So you have multiplied by negative cosine of negative 90. Okay? Negative because the vector here is negative AX. Okay, so it becomes negative cosine. So the answer here should be, so this one is 1 because unit vector 1. So you have negative 10 cosine. Now cosine 90 minus P is sine of P. Okay, the sine of P. So therefore, if you notice, AX dot AP in the table is negative sine P. Okay, because this is equivalent to negative cosine 90 minus P. Okay, so, or you can also use the cosine instead of sine. You can use the cosine. Okay, so, and then you have the P. You can check that the P negative 33.69. If you use cosine, they're the same with the sine. Okay, so cosine 90 minus negative 33.69 is equivalent to sine negative 33.69. So what is the answer for your AP? So 10 times negative cosine 90 minus negative 39. Now, this is the same for your problem B and problem C. It's a bit longer. Okay, so we have a correction here. So we have P is the angle P here. You have tangent inverse of y over x. Now, be careful. We have two solution for this. So you have we have negative 33.69 or 146.30 degrees. Okay, now if you notice, we need to choose 146.30 because the drawing here, this is x, then this is y, but since x is negative 2, okay, and y is positive 2, negative 3, and then positive 2, so here. So since the reference of the angle is here, P, so P should be equal to 146.30. So the one we chose, which is negative 33.69 here, okay, in this is actually in this part, okay, negative 33. When y is equal to negative 2 and then x is equal to positive 3. So we choose 146.30. So now if you substitute P in the previous problem here, instead of negative 33.69 in AR, in your A theta, instead of negative 33.69, you replace this one with 146.30, and also it's true for this theta here. So your final answer should be in all negative. Okay, so negative 5.6 AR minus 6.18 A theta minus 5.55 AP. Now, another way to be sure of this, instead of using tangent, we can actually use the cosine. We are given with p, or the the rho 13, square root of 13. So we know that in this drawing, okay, in the top view, you have this drawing here, no? You have p, and you have x, then you have rho. So you actually get p is equal to cosine inverse of x over rho. Okay? So this is cosine inverse of negative 3 over square root of 13, which gives us 146. Okay? So this is a error, an error that is not obvious because we are highly dependent on our calculator, and if we analyze the problem, then we actually can now the question is why is it that our calculator give us negative 33.69? Because it is closer to 0. Our calculator uses numerical method, and the initial value is 0 or 1, or somewhere that one, no? 0 or I think our calculator uses initial value of 0, and then negative 33.69 is closer to 0. That's why when you arctan, and then immediately the result is negative 33.69. It uses some numerical method. Okay, so that's it. So our final answer is all negative instead of all positive.